Last thing we need to talk about to be able to do the last type of configuration are the blocks of the periodic table. So we can divide the periodic table up into sections that we call blocks. So the first two, so groups 1 and 2, we call the S block. Groups 13 through 18, so here through here, we call them the P block. Transition metals in the middle here we call the D block, and then the lanthanides and the actinides, those two rows at the bottom, we call the F block. Now what this allows us to do is we can actually use the periodic table to do those electron configurations instead of going through and using all the arrows and doing that like we learned earlier. So if we have this and we can remember where the S block, the P block, the D block, and the F block are, then we can write those configurations that way. So if we look at this, if we remember talking about orbitals, we talked about the S orbital has one orientation. Each orientation holds 2 electrons, and notice there are 2 blocks in the S block. If we go to the P block, remember P orbital had 3 orientations. Each one held 2 electrons, so for a total of 6. So if we go 1, 2, 3, 4, 5, 6, there's 6 across in the P block. The D orbitals had 5 orientations, each with 2 electrons. So if we count all the way across, there's 10. The F orbitals had 7 orientations, 2 across, or 2 each, so this would go 14 all the way across. So it matches up very nicely with the orbitals that we had talked about before. Okay, so before I show you the last notation, I'm going to show you how to use the periodic table to do those notations without having to do the arrows. So carbon was one of the ones that we did, so let's look at carbon. So if we're going to do carbon, again, we can use the periodic table without going through and doing the arrows. So we start here, and you have to imagine these being numbered down the side. Now you may or may not be able to see this, but this is 1, 2, 3, 4, 5, 6, 7. So our periodic table in the classroom has those numbers on it, and most of the other ones you have those too. So the 1 is the number in front of the letter. The letter comes from whatever block you have to go through or you end up in. And then the number is how many places you had to count to get through it or to get to that particular block. Okay, sounds a little confusing, but it's not too bad. So to get to carbon, which is right here, this is where we're looking for, we're going to start all the way up here with 1, and this is the S block. So 1s1, 1s2. When we leave that block, we're going to write that down. So 1s2. Then to get to carbon, now we have to go through the 2s. So I have to go through 2s2. So I'm leaving that block, so I'm going to write that down. And then now I'm in the P block over here, and this is 2p2. So to get to carbon, these were all the ones I had to go through to get to the element that I was looking for. Okay, I'm going to erase those marks that I just made here, and we're going to do a different one. Let's erase carbon. Okay, so now let's look at, let's do gallium. Okay, because it gets a little trickier as you go through the D block or the F block. So for gallium, which is right here, so this is where I'm looking for, I have to go through the 1s2, through the 2s2, through the 2p6. Now I'm in 3, so this is the 3s2. This is the 3p, go all the way through that, 3p6, the 4s2. Okay, now when you go into the D block, because of the filling order, you subtract 1 from the period number. Okay, so the period is 4, so when I go here into the D block, I'm actually going into the 3D. So 3D10, because I'm going all the way across. And then back over here, I hit the P block again, and I go back to my original number, which was 4p1. Okay, now the only other tricky thing about doing this is if I happen to go into the F block down here, so this is my F block, the F block is actually period 6 and period 7. So if I go into the F block, I subtract 2 from the period number. So this is 6, but this is actually 4F all the way across, and this is 5F all the way across. We're going to tend to stay away from those for the most part at this level, but eventually we'll come back to that in AP Chemistry. Okay, so this takes us to our last notation, And our last notation is called noble gas notation. And this is an even shorter cut when you're writing these configurations. This is especially helpful when you're dealing with things that have many more electrons than things at the very top of the periodic table. So when we do this, the core electrons are designated with the symbol of the corresponding noble gas. So we're going to use the noble gas and say this particular element has the same configuration as this noble gas plus whatever we write behind it. This also takes into account this whole S block, P block, D block, and F block that we just talked about. Okay, so let's go through and do a couple practice problems with this. So here's nitrogen. Okay, so there's nitrogen on the periodic table. So what we're going to do is look at the noble gas that comes before it on the periodic table. So its noble gas is helium. Okay, so when you do the noble gas configuration, you put the noble gas in brackets. So we're going to say nitrogen has the same configuration as helium plus whatever comes after it. Okay, and then here's our numbers again. I'm just going to write the first couple because we don't need all of them. So then that takes the place of everything before. Okay, so all we care about now is what it takes in that row to get to the element. So here I have to go through the 2s2, and then I'm in the 2p, and I have to go 1, 2, 3. So I have 2p3. So the 2 comes from the number out here. I go through the S block 2, and then I go into the P block 3. Okay, let's try another one. So now we're going to do magnesium. Okay, so here's magnesium right here. I'm going to put my numbers on the outside for us. Okay, so magnesium, the first thing I have to figure out is its noble gas. So I'm going to look at the noble gas that comes before it. So it's number 12, so I go 11 and 10. So here's its noble gas. Neon. Okay, so I'm going to put neon up here in brackets. Then I'm going to go to the third row where the element is, and I'm going to go through it until I hit magnesium. So for this one, it's going to be easy because all it is 3s2. And then I'm there. Okay, next example, a couple more here. Now we're going to look at gallium. Okay, so gallium we learned in the previous slide, or previous couple slides, was that gallium is after the D block, and there's a couple special rules for the D block. So first thing again is we're going to find its noble gas. So if we go backwards, the noble gas that comes before it is argon. So argon goes in brackets. Then we go to the row it's in, and we're going to count across till we get there. So I have to go through 4s2. And if you remember from a minute ago, when we go into the D block, we have to subtract 1. So this goes to 3d10 to get all the way across it. Then right here, I'm back in the P block, 4p1. Okay, so this is the exact same thing we've been doing in terms of how many elements or how many electrons. The difference is it's a little bit faster, especially when you have something lower on the periodic table. All right, one last example here. I'm going to do tin. Actually, we're going to do 2 more examples. One's going to be kind of a bonus one. Okay, so here's tin right there. Noble gas. My number's over here. 2, 3, 4, 5 this time. So here is tin's noble gas, krypton. Then I'm going to go to the row that it's in. So I have to go through 5s2, subtract 1 for the D block, 4d10, then go back to my original number, 5p2, and that gets me to 10. Okay, last example shows what happens when you have to go through the F block. Okay, so this one, we're looking at lead. Okay, so lead's noble gas is xenon. So there's xenon. Okay, then after we get to xenon, we're in row 6, so 6s2. Okay, now at this point, see how this is number 56? This goes down to the F block here. So remember the F block, we subtract 2, so instead of 6F, it's actually 4F. To get all the way across that, we have to go 14. So 4F14. So that takes us all the way through here to 70. Now I go back up to 71. Now I'm in the D block where I subtract 1. So that's 5 D10 to get all the way across. Then here I go back to 6 because I'm back to the P block, and I have to go 2 over in the P block. So 6S, oops, I forgot my 2 here. 6S2 goes down to the 4F 14, back up to 5D10, and then 6P2. Okay, now those on our test will probably be extra credit at this point, but I just wanted to show you one of those so you could see.